Oh, you can focus. There you go. So we already have a technique for computing arc length of a curve described parametrically. Of course, this time around, I just want to consider the parameter to be theta, because now I want to talk about the length along a curve if it's given as a polar graph. Now remember, y is just r times the sine of theta, or r is a function of theta. So to differentiate, like we did before, I will use a product rule. So I can do this. And of course, dx d theta likewise was this. I don't remember it. I just do it in my head. If x is equal to r times the cosine of theta, differentiating using product rule, do to the first times the second, etc., etc. Now, expanding, I'm afraid, is going to give me a mess. Well, initially it gives me a mess. I promise. It will clean up quite nicely. All right, so can I slow down real quick? You know what? This is not going to work. Only because I have such little board space. Can I just cheat? And let me talk my way through this. If I were to expand this binomial square, I get 3 terms, but the first term is this thing squared. But I will likewise, when I expand this binomial square, get this thing squared for the first of the 3 terms. Now, this thing squared plus this thing squared, if you factor out the drd theta squared, gives you left over sine squared of theta plus cosine squared of theta, but that's just 1. So the first 2 terms in expanding both these binomials combined into a nice clean this. Now, as far as the last of the 3 terms after expanding this binomial square and after expanding this binomial square is going to be r squared cosine squared theta and a positive r squared sine squared theta. Here too, factor out the r squared. What's left over is cosine squared of theta plus sine squared of theta, but that's just 1. Now, I did miss the 2 middle terms, but the middle term here is the same as the middle term here. With the sign change, they cancel. And so here is what's going to be in my back pocket as a tool to compute a portion of the length of a curve if it's a polar graph. So let me add that to our list. So my last one item I want to discuss. We just turned out, I shouldn't say that, we just determined length of an arc is given as such if I got a polar graph. And we're integrating respect to theta. It's example time.